right, so today we're going to look at slopes of lines. And so I gave you the study guide on purpose so you wouldn't have to write so much about something you hopefully already know. So one of the important things on here is your slope formula. Let's get that clear. Let's see if I can get it clear. There we go. All right, so if you don't know your slope formula already, you're going to use this a lot today. So given your points, and I would definitely make sure that you label your points x sub 1, y sub 1, x sub 2, y sub 2 when you get them. And then these are two postulates and theorems. They are on your flashcards. This one right here, the slope of a vertical line is undefined, is not a postulate or a theorem. It's just something that you're supposed to know. What is the slope of a horizontal line? Yeah, so slope of a horizontal line is equal to 0. And then the equation of a horizontal line would be y equals a number, any number. So horizontal lines go through the y-axis. That's why the equation is y equals. There will be no x in that equation. And then the slope of a vertical lines go through the x-axis, and so it's going to be x equals a number. So when you only have one variable in x or y, you should know that it's vertical or horizontal. If when you're finding your slope, you get 0 in the denominator, is that a 0 slope or an undefined slope? 0 in the denominator. Why do I hear silence? If 0 is in the denominator, can you have 0 in the denominator of a fraction? No. So what kind of slope? Is it going to be 0 or is it going to be undefined? Undefined. You are not allowed to say no slope. There's no such thing as no slope. A line either has a slope, 0 is considered a slope, or it's undefined. So you can use the abbreviation UD for undefined. If your 0 is in the numerator, what's the slope? 0. All right, so know those differences. Then you need to know these. And these you should already be aware of from last year. Two lines have the same slope if and only if they are parallel. Now, notice that they put in here in non-vertical. I mean, technically vertical lines have the same slope, they just don't have a slope, it's undefined, and that's why they're saying so long as they're non-vertical. But vertical lines can be parallel, can't they? You're just going to come up with an undefined slope. And then this one says two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So remember, perpendicular slopes are always opposite signs and reciprocals, because those are the kind of numbers that give you -1. So if I have a slope that is equal to 2/3, the perpendicular slope would be what? What's the reciprocal of 2/3? 3/2. And what is the opposite sign? Negative. If I multiply those two slopes together, don't I get a -1? And the reason why they said non-vertical is because if I have a vertical and a horizontal line, this slope here is 0. This slope here is undefined. Can I multiply 0 times undefined to get -1? No, that doesn't mean that a vertical and a horizontal line cannot be perpendicular, but this is the one situation where their slopes will not multiply to give you -1. So that's the only time. So then there's a little example here, so this will suffice for your notes, and then we're going to do a couple of problems. So here they say, find the slope of the line L that passes through 2 points, state the slope of the line that's parallel, and then state the slope of the line that is perpendicular. So they've gone through, and if I were you, I would label this as, right next to it, x sub 1, y sub 1, and then x sub 2, y sub 2. Doesn't matter which is point 1 and which is point 2. But you want to make sure that you're putting them in the formula correctly. I will always draw the formula with the subtraction signs in first, and then I'll put the numbers into the formula, because otherwise when you try to subtract a negative, oftentimes for this I get just 3 minus 5. And then you end up with the wrong signs. So So they end up with negative 8/3. Wouldn't the parallel line have the same slope? It was kind of a trick question. That's why the parallel slope is negative 8/3. And the perpendicular slope, what's the opposite reciprocal? Positive 3/8. And so that's why they have the perpendicular slope there. All right, so let's do one on our own. Here we're just finding the slope of the lines passing through these points. So we're going to do number 1 and number 4. So I'm going to start off with x sub 1, y sub 1, x sub 2, y sub 2. I'm going to use the main formula. And there's my subtraction signs. Plug in the numbers where they belong. Your y's always go up top. Remember, slope is up, down first, and then right, left. And up, down is along the or the y-axis, and right, left is along the x-axis. So I've got my y's first, and so 12, and then y sub 1 is negative 4, x sub 2 is 8, and then x sub 1 is negative 2. Remember that your points should be vertical to each other. So 12 and 8 belong to the same point. They better be vertical. And negative 4 and negative 2 belong to the same point. You do not want your points to be diagonal to each other. So it does make a difference as to the order. So then add the opposite. And we end up with 16 over 10. Does that reduce? To what? 8/5. So what is the parallel slope to 8/5? Parallel slope. 8/5, same slope. What's the perpendicular slope? Negative 5/8. Good. All right, so you do number 4. Bless you. So discuss your slope with those around you. So what slopes I'm hearing different slopes. I hear what? Negative 1/2. What else did I hear? I heard other slopes. 16 over 17. Is that the other one? Or over 7? Watch your signs. On this one, there's a lot of 15s and a lot of negatives, right? So it's really helpful if you put in that negative first. Did you mix? Oh, you did number 2. Okay. So what did you get for number 2? Number 2, 16/7 is correct. Negative 16/7, yes. All right. So yes, at least you did do it correctly. Good, good. So what is the parallel slope to this one? Negative 1/2. What's the perpendicular slope? Positive 2, right? So you wouldn't say 2 over 1, just positive 2. Perfect. All right, so then look at what they're asking you to do here. Then this one says, find the slope of the line parallel to the line passing through each pair of points. Then state the slope of the line perpendicular to the line passing through each pair of points. Are they asking you something different than above or the same thing? Find the slope of the line parallel to the line passing through the pair of points. So here's the pair of points, right? Can we find the slope of that line that would pass through those points? I'm just using the slope formula, right? And then they want you to state the slope of the line that's perpendicular, right? And the slope of the line that's parallel. Is that any different than what we just did? No. Here's what I'm going to show you, how to write the equation of a line. So you ready? So we're going to go ahead and write the equation of a line that's parallel and the one that's perpendicular. So we'll do one of those, and let's take 7. So we'll do number 7. So the first thing I have to do, I want to find the equation of the line that's parallel to this line. Oh, I'd have to have a point that it goes through. Let's choose, we'll choose 0, 0. See if that works, since I'm flying off the cuff. We're going to choose the point 0, 0. I don't know if that'll work, but we'll find out. All right, so this is a point on my line right here, 0, 0. So let's label this as x sub 1, y sub 1, x sub 2, y sub 2. Find your slope. Doesn't that reduce to 7/3? Right? So what is the line parallel? What's the slope parallel to this? 7/3, right? And what's the slope perpendicular to this? -3/7. So if I were to write the equation of the line that is parallel to this one, that goes through this point, I would use this slope and this point, wouldn't I? Right? Have you seen the point slope formula? Yes or no? Have you seen that? So if I have a point and a slope, I'm going to write the equation of my line using a point slope. So for our purposes here, this is my x sub 1 and this is my y sub 1, and I'm going to find my parallel line, so I'm going to use my parallel slope. So I'm going to replace into only these 3. So I'm going to replace this value here, this value here, and this value here. The plane x and y stayed plane x and y. So I have y minus, what's my y sub 1? 0. And then I have equals, my slope is 7/3 for my parallel line. And what's my x sub 1? 0. So if I perform the operations, I chose 0, 0 on purpose because it's pretty simple. What's y minus 0? Y equals 7/3 times x. And what's 7/3 times 0? 0. So I don't have to write that. So my parallel line, this is my parallel line, would be y equals 7/3 x. So find your perpendicular line. So same thing. Y minus, same point, 0, 0. But this time I'm going to use my perpendicular slope. Isn't my perpendicular slope -3/7 times x minus 0? Y minus 0, 0. -3/7 times x. Whoops. And -3/7 times 0 is 0. There's my equation of my perpendicular line. Now, what if you were given 4 points and you had to decide if the lines going through those 4 points were parallel or perpendicular? What would you have to do? Let's say that I gave you these 4 points right here, and I said, I want you to tell me if GH and MT are parallel or perpendicular to each other. How would you determine that? What do you have to know to determine parallel and perpendicular? Slope. So wouldn't you find the slope of these 2 points, find the slope of those 2 points and compare them? If the slopes are the same, what do you conclude? They're parallel lines. If the slopes are opposite reciprocals, what do you conclude? That they're perpendicular. What if they're neither? They're not the same and they're not opposite reciprocals, what do you conclude? Are they parallel or perpendicular? No. So just because they say determine if the lines are parallel or perpendicular, they might not be. So your answer might be they're not. And your proof, because remember this is a class of proof, is to show the slopes and compare them and show that either they're the same, or they're opposite reciprocals, or product is -1, or that neither one of those two situations really what you're working with today. Sorry for the squeaks.